In this video, we are going to study hypergeometric distribution. Let's assume that we have an urn with 30 blue chips in it. And let's say there are also 20 red chips in that urn. Let's assume that we are drawing a sample of 7 chips without replacement. So if we are drawing a blue chip from our urn here, we are not putting it back. The goal of our video here is to try to answer a question. What is the probability that, let's say, we will draw 5 blue and 2 red chips? Now, if we were drawing those 7 chips with replacements, then it would be a problem of binomial distribution. So probability of drawing a blue chip from our urn here would always stay as 3 out of 5. However, we are not putting the chips back that we have drawn, meaning that our probability of drawing, let's say, blue chips at each draw is not going to remain constant. So the draws are the probability at each draw of drawing, let's say, red or blue chip is not constant. So let's try to answer our question. What is the probability that we'll get 5 blue and 2 red chips in our sample? As usual, let's start by finding our denominator. There are a total number of 50 chips in our urn. So there are a total number of 50, choose 7 number of ways of drawing a sample of 7 chips out of 50. Out of those, the following are going to satisfy our stated condition of drawing 5 blue and 2 red chips. So we'll have first operation for a choice of blue chips and second operation for a choice of red chips. There are 30 blue chips. Out of those, we have to choose 5 of them. So 30, choose 5, number of ways of choosing blue chips. There are 20 red chips, so 20, choose 2, number of ways of choosing red chips out of those 20. Now, the scenario that we have considered here is known as hypergeometric distribution. So suppose an urn contains n r red chips and omega white chips, where r plus omega equal to big N. So big N is the total number of chips in our urn. If a sample of small n chips are drawn at random without replacement, and if k denotes the number of red chips selected, then probability of drawing k red chips in our sample of small n chips is given by the following ratio here. Now let's take a look at the following problem. So we have a jury, which are chosen a jury of size 12. Those are chosen from a pool of 25 jury members. And out of those 25, 23 would always return a guilt verdict. So let's color them in red. So we'll have 25 red or guilty chips in our urn. The other two potential jurors would vote to acquit regardless of the facts. So we have two not guilty chips in our urn. So there are two blue and 23 red chips. What is the probability that a 12-member panel chosen at random from the pool of 25 will be unable to reach a unanimous decision? So what is the probability that if we choose a pool of 12 jurors, out of those 12, either we'll have one guy disagreeing, so one blue chip and 11 red ones, or two juror members would approve a not guilty verdict, while other 10 will say that our defendant is guilty. So this problem is also modeled by hypergeometric distribution. So we're looking for the following probability. Probability is that we'll have one blue and 11 red chips in our sample, or probability is that we will have two blue and 10 red chips in our sample. So there are 12 sample, the size of our sample is 12. So there are 25, choose 12 total number of ways of choosing a panel of 12 jurors out of 25. Now, the first probability here, there are two blue chips in our urn. So to choose one number of ways of choosing one blue chip out of the two available in our urn, multiplied by there are 23 red chips, so 23, choose 11 number of ways of choosing 11 red chips out of 23, plus the second probability over here is given as 25 choose 12. Now we'll choose two blue chips. There are two blue chips in urn. Out of those, we choose two, multiplied by there are 23 red chips. Out of those, we choose 10. So 23 choose 10. This concludes our video on hypergeometric distribution.